This video is going to cover a quick review of simplifying square roots. Now, there are multiple ways to do this. I prefer the factor tree method. So this is great for more visual people. So what you're going to do when you have a square root you need to simplify. Like number one, I have the square root of 84. What I'm going to do is draw my little tree. So what I want to do is break this down into two numbers that multiply to equal 84. This is a bigger number, so let's see. It's even, so I can divide it by 2. So 2 times 42 gives you 84. So now I would do the same thing with the next two numbers. So I have 2, but 2 is already prime. There's no numbers that multiply and equal 2 except for 1 in itself. So there is no factor tree coming out of the 2. But I know 6 times 7 is 42, so I'm going to break down 42 into 6 times 7. And then I would continue breaking down all the numbers that I can until I hit all prime numbers at the end of my factor tree. So I know 3 times 2 is 6, 7 is prime, so there's nothing to do with that one. Now, when it comes to larger factor trees, it might help to organize this a little bit better. So as soon as you're done with a number, you can cross it out. So I created this factor tree, so I'm done with the 84. I created this factor tree, so I'm done with the 42. I created this factor tree out of the 6, so I'm done with the 6. So this kind of shows me the only numbers I'm looking at are the ones on the ends that are not crossed out. So I have 2, 3, 2, and 7. So all I did was count around the edge of the tree. So now what I want to look for is pairs of numbers. So I want to look for two numbers that are the same. So it looks like I have 2 2s. So what I'm going to do is put 1 2 on the outside, and that gets rid of both 2's that I circled, because basically what I'm doing is taking out the square root of 4, which is just 2. So I have my 2 on the outside. That eliminates both of these 2's. The only things left over are the 3 and the 7. So because they're both, they don't have a pair, they're both single numbers, they stay inside the square root, and we multiply them together. Whenever you have multiple numbers, you multiply them together. So the square root of 84 is equal to 2 times the square root of 21, or 2 root 21. So let's look at one more example. So the next one I have is the square root of 360. So this is a little bit bigger, so we're going to have a larger factor tree, so it's going to be really important we stay organized with it. So two numbers that multiply to equal 360. You can start with whatever two numbers you want. Right away I see it ends in a 0, which means I can divide it by 10. So 360 divided by 10 is 36. So those are the two numbers I'm going to work with. So now I have 10. I can divide that by 5 and 2. 36, let's see, I could do 2 and 18. And then I know 18 is 2 times 9. 9 is 3 times 3. So if I look at the ends of the tree, I got 5, 2, 2, 2, 3, 3. All of those are prime numbers. So that means I am done creating the factor tree. So now what I want to do is kind of go back and cross out those extra numbers that I don't need just to organize this. So again, every time you create that tree, you're done with the number above it. So here's a tree, I'm done with the 10. Here's a tree, I'm done with the 36. So no 18 and no 9. So that shows me I'm working with just the ones at the edge, the blue ones that are left over. So I want to find pairs of numbers. So right here I have a pair of 3's. So I put 1 3 on the outside. That gets rid of both 3's at the same time. Next thing, looks like I got a pair of 2's. So again, I put that on the outside. And whenever we have multiple numbers, multiply them together. And then left over, it looks like we have a single 5 and a single 2. So they get stuck inside the square root. Since they don't have a buddy, they can't leave the square root symbol. And then just simplify your final answer. We have 6 times the square root of 10. And that would be your final answer. So hopefully this video kind of helped solidify what you were thinking about simplifying square roots, make sure you do some practice problems on your own.